As mentioned before, a class is like a blueprint. For instance, when we create the player class, it helps us create various objects that store details about different players. But how does the class actually make these objects? That's where constructors come in. Constructors are special methods that tell how to create new objects from the class. In this lecture, we'll talk about constructors and how to define them in a class. Hello guys, welcome back. Okay, whenever we make a new object from a class, the constructor runs automatically. Its job is to get everything set up for the new object. Constructors usually fill in the default values for any data stored in the object. This helps initialize the object. In C#, if we don't write our own constructor, the compiler adds a default one for us. This is called the default constructor. The default constructor sets all the data in the object to default values. For example, numeric types like int are set to 0. Booleans are set to false. Reference type objects like strings or team are set to null, and so on. Okay, when we wanna create a new player object, we use the new operator. This reserves memory for the object and runs the constructor. The player class doesn't have its own constructor defined, but C# helpfully adds a default one behind the scenes. This lets us create player objects even without writing a constructor ourselves. When the default constructor runs, it sets each piece of data in the object to a default value. Remember, when we use auto properties, the C# compiler creates hidden fields behind the scenes. In this case, 5 fields are created respectively for each property. Okay, sometimes we wanna assign our own default values instead of using the default values provided by the default constructor. For example, if we set a default value for a property, like setting age to 18, then the default constructor doesn't need to change it to 0. This is because the value is already set to 18. Alright, if we wanna customize how the object gets set up, we can define our own constructor. This gives us control over the initialization process. Okay, let's open up the VS Code and define a constructor to the player class. Okay, the constructor signature only includes an optional access modifier, the name, and its parameters. Constructors can have different access modifiers like public, private, and others. These access modifiers determine how users of the class can create instances of the class. Okay, let's make it public because we wanna create instances outside the class. In C#, it's common practice to define constructors after the properties. Okay, if we define a constructor without specifying an access modifier, it's automatically considered private. This means that the constructor can only be accessed within its own class. Okay, the name of the constructor must be the same as the name of its class. So let's go for player. As you can see, a constructor is similar to a method, but it doesn't have a return type. Actually, a constructor is a method with the same name as its class. Okay, so far there are no errors in the main method. Now let's add a name parameter to it. And inside the constructor, assign the name parameter to the name property. As you can see, as soon as we add the parameter, errors appear in the main method. The compiler complains that there is no argument provided for the name parameter. This means that if we declare at least one constructor in a class, C# doesn't automatically provide a default constructor without parameters. To fix this, let's pass the name argument to each of the instantiation expressions. Now, behind the scenes, when we create these 4 players, 4 player objects with names are created in the heap, and each of the player variables points to one of them. The constructor sets the name value passed in, but other fields stay at their defaults. Okay, to make player 2 a captain, we define a second constructor that takes name and a bool for its captain. As we said, constructors work like methods, so we can overload them. Here, just like methods, we're creating 2 different versions of this constructor, known as constructor overloading. Now, when we instantiate the player class with 1 parameter, the first constructor will be invoked. But for player 2, let's provide the second argument. In this case, the second constructor will be invoked, and it will set this captain field to true. Similarly, we can define another constructor to set the age and jersey number values as well. Let's pass the age and jersey number arguments to player 3. Now, when we pass 4 parameters to player 3, the third constructor will be invoked. Okay, in the upcoming lecture, we'll talk more about constructors. See you soon.